class, let's talk about half-life, right? So sabi natin class, what is half-life all about? So one important parameter na nagagamit natin using the half-life would be time to reach steady state. Kasi like I told you a while ago, okay, you need to make sure that the drug is at steady state prior to getting or prior to extracting blood from the patient to determine drug concentrations. Okay, so half-life is an important parameter to determine that. Okay, so half-life class simply express the period of time required for the concentration of a drug to decrease by 1/2. Okay, so halimbawa, from 100% to 50%. 100% to 50%. So ano oras niya na-reach yun? That is half-life. So 50% to 25%, kasi half ng 50 eh. Ano oras niya na-reach yun? That will be the half-life. Half ng 25, 12.5, and so on and so forth. So ganon. Okay? So it's the time required to decrease the initial dose of a drug by 50%. And the units class for half-life will always be units of time. So it could be in days, months, seconds, minutes, hours. Mas common ang hours. Okay? So why is it important? Half-life class is basically used to determine your dosing interval. Okay, we'll talk more about this class once we reach multiple dosing intervals. Okay, wag nag-start tayo mag-compute for maintenance doses. Okay, so it's necessary to obtain the desired CP of the drug. So generally, the dosing interval is almost the same. I'm not saying all the time, but it's almost the same as your half-life. It can be used to predict how long it will take for the drug to reach steady state, like I've mentioned earlier. Okay, it predicts the accumulation of a drug in the body. So as I've said, takes about, for steady state concentrations to reach, takes about 4 to 5 half-lives. Okay, and predicts how long it will take for a drug concentration to decrease to a lower concentration. Approximately 96% of your drug will be eliminated after 4 half-lives, provided you do not administer additional doses. I will repeat this. Ulitin ko lang. Okay? A drug class, the concentration of a drug will be reduced to 96% of from its original concentration after 4 half-lives, provided no additional drug is administered. It's only single dose. Okay? Okay. So after 4 half-lives, 96% of the drug will be totally eliminated na. Are we clear? It's something you need to remember. Now, how do we compute class for half-life? Of course, class, ang pinaka-applicable, or sorry, ang pinaka-useful clinically class are drugs following first order. Sabi nga natin, 95% of your drugs, 90 to 95% of the drugs in the market follows first order kinetics. Magpa-follow lang naman siya ng zero order once na-reach ang saturation point. Okay? Pero it always starts as a first order process. Okay? So the first order half-life class is constant for the first order half-life is constant for a first order process. So it's related to the first order rate reaction. So no matter what the initial amount or concentration of the drug is, the time required for the amount to decrease by 1/2 is constant. So meaning class, a first order half-life is concentration independent. Kasi the first order half-life will always remain the same. But, ayan yung but, first order elimination rate, okay, is concentration dependent. Okay? It's concentration dependent. Meaning, the rate of elimination, okay, is directly proportional or is dependent on the initial concentration. Kaya siya concentration dependent. Okay? See the difference? First order half-life versus first order elimination rate. So are we clear? Kasi class, pag yan ay zero order na, advanced na ako, no? Hindi pala pa nga tayo sa zero order half-life. Zero order half-life kasi class is concentration dependent, meaning the half-life is very dependent on the concentration remaining inside the body. While for the zero order elimination rate, okay, Zero order elimination rate is concentration in dependent. Okay? Meaning, kasi ang assumption natin, pag zero order na yung elimination rate, ibig sabihin, na-reach mo na yung saturation point. So no matter how high I give the concentration of the drug, okay, no matter how high the concentration is, rate of elimination will remain the same. It will remain constant. Okay? Okay. So the formula class for half-life is simply 0.693 divided by K. As simple as that. The half-life is 0.693 divided by K. So if I want to compute for K, provided I have my half-life, ang formula niya lang is simply 0.693 divided by the half-life. So class, as long as you have half-life, you will always determine, you can always compute for K. Or as long as you have your K, elimination rate constant, you can always compute for your first order half-life. Are we clear? Nagkataon class, half-life is always found in your drug inserts. Andiyan lang yan. So, ang daling mag-compute ng K. Pag may K na ako, provided I have my CP sub 0, okay, which is usually computed, diniderive yun, ang CP sub, ang CP sub 0, or the initial concentration, kinocompute natin yun, we can always determine class the resulting plasma concentration after a given time. So, are we clear? Okay. So for a first order process class, again, this one is a cross-sectional graphing paper. So obviously, dahil cross-sectional graphing paper ito, ang itsura ng line ko is a curve. Okay? So first order half-life happens. So 0.2 ang initial concentration ko. Kailan siya naging 0.1? Half ng 0.2 is 0.1. That's after 7 hours. So yung half naman ng 0.1, 0.05. Kailan siya naging 0.05? Nandito, after 14 hours. Yung half ng 0.05, 0.025. Kailan siya nangyari? After 21 hours. So ano na-notice natin, class? The half-life is constant. The half-life is 7 hours. Meaning the drug is reduced to 50% every 7 hours. Now that is the property class of a first order half-life. Okay, it's constant. Hence, class, its clinical value is very important kasi constant yung half-life niya. Okay? Okay. So what about class for zero-order half-life? For zero-order half-life class, simple lang din naman ang equation niya. All you need, class, is your C sub 0 or the initial plasma concentration. So for zero-order half-life class, it's not constant, unlike that of first order. So it's proportional to the initial amount or concentration of the drug, and is inversely proportional to the zero-order rate constant, which is the K sub 0. Okay, because the half-life changes periodically as drug concentrations decline, this has little practical use. Okay? Okay, so class, ang half-life for zero-order kinetics is simply half of the original concentration divided by your K sub 0 or elimination rate constant. Zero-order elimination rate constant. Okay? So looking at this one, class, tingnan nyo. Straight line siya sa cross-sectional graphing paper, so zero order to. Half ng 0.2 would be 0.1. Kailan na-reach? Hindi ko alam. Somewhere here. Pero tingnan nyo, class. As time goes by, as the plasma concentration decreases, so is the half-life. So does the half-life. So anong sinasabi nito? Okay? As plasma concentration decrease, it's directly proportional. So as the CP or the drug concentration, as the drug concentration decreases, it also causes a decrease in the half-life for zero order. So hindi siya constant. Unlike that of first order reaction, okay, half-life remains constant. Okay? All right. So let's do this one. Sorry, ako pala muna. So let's have a sample problem here. A pharmacist dissolves 10 grams of a drug in 100 ml of water. The solution was kept at room temperature and the samples were removed periodically and assayed for drug concentration yan. Based on the following data obtained by the pharmacist, compute for the rate constant. Right? So here, class, use the table in the next slide. Okay, so isusulat ko lang muna yung natin, ha. Ito na pala eh. Okay? Alright. So look at this, class. Sinabi ba sa problem kung zero order or first order? So obviously, class, hindi sinabi, right? Hindi sinabi. But we were given a data sets. Binigyan tayo ng data sets. So anong gagawin ko dito? Ipa-plot ko ba? Ayoko, tinatamad ako eh. Okay? Pero class, looking at simply looking at this one, looking at the data sets. Okay? Tingnan nyo. Here are the times and the corresponding concentration. So at 0 time, 100 milligrams per ml. So that's my Cp sub 0. Obviously, kasi that's the concentration at 0 time. Okay? Tingnan nyo class ha, proportional yung increase in time, proportional din yung pag-decrease sa concentration. Proportional. So dahil proportional class, ibig sabihin, this is already following zero order. So in my eyes class, alam ko na agad na zero order to kasi proportional yung pag-decrease ng concentration with respect to time. Okay, with respect to time. Alright? Now class, kung ayaw mo talaga, gusto mo talaga makasigurado, pwede mo namang i-plot, walang problema. Okay? You can plot it in Excel. I think you know how to do that naman. Okay, hindi ko napapakita ah. Pero you can plot this pag nagbukang straight line siya sa Excel, goods. Sabihin zero order yun. Right? So in this case class, sabihin ko na zero order to. So ang question dito is to determine half-life. Okay? So ang question is half-life, yung zero order equals unknown. Hindi natin alam yun. So now class, ano ba ang formula natin for half-life? Sabi natin, zero order half-life is equal to half of the initial plasma concentration divided by your K sub 0. Okay. Do I have C sub 0? Ano ba mga given ko dito? Given ko dito would be, I have C sub 0, correct? So ito yung required. So I have C sub 0. So what's my C sub 0? 100 milligram per ml. Ito yun. This is my C sub 0 or my initial plasma concentration or my plasma concentration at 0 time. Okay? Ano ang kulang ko to compute for half-life? What I'm lacking class is K sub 0. So, how do I get K sub 0? Babalikan natin ngayon ulit ang formula ng ang formula ng zero order reaction. So sabi natin class, zero order reaction is Cp equals negative K times T plus K times T plus C sub 0. Okay? All right. So class, for me to get K sub K, elimination rate constant, transpose the formula. So, pakita na natin transposition. Okay, so remove C sub 0 here. So negative C sub 0, both sides of the equation, para ma-cancel out na to. So that would be Cp minus C sub 0 equals negative K times T. Divide both sides of the equation by T para makuha ko ang K. Okay, so this would give me Cp minus C sub 0 over T equals negative K. Siyempre, hindi pwede yun. Multiply both sides of the equation by negative 1. So ang lalabas would be K equals Ln na naman. C sub 0, minus C over T. So that's how I will get my K sub 0. Get a 0 dito. Para alam natin na that's a zero order process. Alright? So class, do I have C sub 0? Yes, that's 100 milligram per ml. Do I have a concentration at its given time? Ako nang bahala pumili dito, class. Pili lang ako. Okay? So usually, class, ang pipiliin kong plasma concentration dito will always be the last. That's a personal preference. Why do I always choose the last? Kasi class, the last plasma concentration, most likely, malaki ang possibility at equilibrium na yan. Okay? Ibig sabihin, stable na yung rate of reaction dyan. Yung rate of elimination, stable na. Kaya lagi kong ginagamit, class, ang mga huling data. So I always use the last data set. Again, you can use any data set here. Okay? Any data set here. In my case, just my preference, okay, this is my preference, I always use the last data sets. So therefore, ang plasma concentration na gagamitin ko would be the Cp, okay, would be 70 milligrams per ml, and the time would be at 12 hours. Okay, at the 12th hour. So therefore, ang CO ko would be 100 minus 70 divided by 12. Hindi ko na nilagyan ng units class, ha? Okay. K sub 0. So, K sub 0 ko would be 100 minus 70 would be 30 divided by 12. So, that would give you 2.5 milligram per ml per hour. So, now I have my K sub 0. Can I compute now for my half-life? Yes, I do believe I can. So, half-life is equal to 0.5 times yung C sub 0 natin, which is 100 milligram per ml, divided by my K sub 0, which is 2.5 milligram per ml per hour. Okay, so milligram per ml, cancel, matitira ang hour. 0.5 divided by 2.5, and you get 0.2 hours. Okay? So the half-life, the zero-order half-life class will be simply 0.2 hours. Eh, bakit 0.5? Mali, sorry. 0.5 times 100. Ay, muntik na ako. Ingat kayo, class, ha? That's 50 divided by 2.5. I am so sorry. That's 20 hours. X. Okay, muntik na. Buti na habol ko. Right, that's gonna be, class, 20 hours. So my zero-order half-life is 20 hours. Ito yung final answer ko. So are we clear? Okay. So class, please take note on how I was able to transpose my formula. Kasi baka may next time, hindi ko hingin ang K sub 0. Ang hiningi ko is, kunwari, T. Okay, given the initial plasma concentration and the time, determine what is the plasma concentration. And so on and so forth. So of course, class, I leave this to your critical thinking. Okay? Skills you to critically think for your own. So class, I might ask those kinds of questions.